Hey guys, it's Leia. Today we will talk about how to solve exponential inequalities. We will see exponential inequalities in this form, where a and b are numbers and the inequality sign can be any inequality sign. In order to solve these exponential inequalities, first we isolate the exponential expression. Next, we rewrite b from step 1 such that b equals a to the power of log base a of b, or b equals e to the power of ln of b, depending on the inequality. Next, depending on the value of a and the inequality sign of the problem, we use one of these rules. The rule for when a is greater than 1 can be applied to any inequality sign as long as a is greater than 1. Just make sure to change the signs. Our final step is to solve the inequality from step 3. If b in the original inequality is an exponential expression with a base equal to a, then you can skip step 2 and move on to step 3. Now let's see some examples to better understand. First example, we have 10 times 4 to the power of x minus 1 is less than 20. First, we isolate the exponential expression. So we divide each side by 10 and get 4 to the power of x minus 1 is less than 2. Next, we rewrite b such that b equals a to the power of log base a of b. b in this case is 2 and a is 4. So 2 equals 4 to the power of log base 4 of 2. Now we can substitute in 4 to the power of log base 4 of 2 for 2. Next, we use this rule since a is greater than 1. So, 4 to the power of x minus 1 is less than 4 to the power of log base 4 of 2 is equivalent to x minus 1 is less than log base 4 of 2. Finally, we solve the inequality from step 3. We add 1 to each side and get x is less than log base 4 of 2 plus 1. Our answer. Next example, we have e to the power of 2x plus 2 minus 8 is greater than 4. First, we isolate the exponential expression. So we add 8 to each side and get e to the power of 2x plus 2 is greater than 12. Next, we rewrite b such that b equals e to the power of ln of b. In this case, b is 12. So we have 12 equals e to the power of ln of 12. We can now substitute 2 to the power of ln of 12 for 12 in the inequality. Next, we use this rule since a is greater than 1. We have e to the power of 2x plus 2 is greater than e to the power of ln of 12 is equivalent to 2x plus 2 is less than ln of 12. Finally, we solve this inequality. We subtract 2 from each side and divide each side by 2. And we get x is less than ln of 12 minus 2 over 2, our answer. Last example, we have 0.2 to the power of x plus 2 is greater than or equal to 6. First, we isolate the exponential expression. This is already done, so we can move on to the next step. Next, we rewrite b. In this case, b equals 6, so 6 equals 0.2 to the power of log base 0.2 of 6. We can plug this in for 6 in the inequality. Since a is not greater than 1 and a is greater than 0 and less than 1, we can use this rule. So our inequality is equivalent to x plus 2 is less than or equal to log base 0.2 of 6. Finally, we solve this inequality. In order to help solve this inequality, you can use this identity to simplify the logarithmic expression. 0.2 is the same as 1/5. So, we use this identity to rewrite our logarithmic expression, and then we subtract 2 from each side. We get x is less than or equal to negative log base 5 of 6 minus 2, which is our answer. In order to get better at solving exponential inequalities, you have to practice solving them. For more help or practice on this topic, visit www.symbolab.com and click on the Practice tab.